Okay, so tonight I'm going to be introducing a framework called OpenRewrite. OpenRewrite is a open source semantic type-aware search and transformation framework. It's a lot of words. It's a mouthful. It's a core framework that will do these transformations, but it also there's an entire ecosystem behind it. We've found that we can build pieces of this to make larger transformations. So I'm going to start by just talking about kind of where it started. OpenRewrite was a project that had originated at Netflix. Jonathan Snyder, who is a founder of Modern, has started this work there. And the initial job was to do some custom code transformations. So Netflix had a logging library that was not dissimilar to SLF or J, and they wanted to migrate the entire company to SLF or J and kind of sunset their logging framework. So basically the logging framework was really similar, but not quite the same as SLF or J's API. It was still called Logger, but the arguments were in different order. And so there were just some subtle things about it that would really make it difficult to do something like with regular expressions. So the team started out trying to solve this problem by using ASTs, and they basically realized with the freedom responsibility culture at Netflix, each repo might have its own stylistic standards for their code. So it then became a problem, like if you transform these ASTs and then try to spit it back out as source code, you'll end up with very different results. So that's the other kind of thing that they had to solve. So it started out that way, and very shortly thereafter, you can start seeing that there are parallels between what they were doing with these custom code transformations, and there are other companies now that are kind of doing similar things that we're aware of. Like one company is trying to sunset an old feature flag library that they had internally. They want to move to launch darkly, so they needed to have some way of automating that. Another company has basically used New Relic and has APIs kind of scattered throughout their code base that are all New Relic specific, and they need to move to a different monitoring system. So again, this is kind of a sweet spot for this type of framework. And again, I promise that I'm light on slides. I think I have a total of 7, and that includes the title and the wrap-up page. So there'll be a lot of demos tonight, and we'll do some live coding at the end. Okay, so as we've kind of been working with Rewrite, we also realized that it's actually really good for patching security vulnerabilities. You figure if you can, migrate a logging framework or, an API for a monitoring system, then sure. Like if you had a CVE out there, there are a lot of technologies out there that'll detect, hey, you've got the security issue, but then what? If you are a large organization where you have thousands of repos, you might get a report that you have, 8,000 repositories that have the security vulnerabilities. Like, well, how do I apply a patch to that? Am I going to have a developer go out there and patch every single one? Well, that's certainly an option. We feel like OpenRewrite's a pretty good candidate for doing this type of stuff automatically. And then again, another similar thing is your static analysis tools. I think every person that's probably on this meeting has some form of static analysis tool that reports some doomsday number of developer days of tech debt, like 800 days or 80 days. Basically, they take an estimate and then you've got like 8,000 of them, and very quickly you're like, wow, got a lot of issues, and they don't always necessarily become like the top of the priority list. But again, OpenRewrite is really good at kind of solving these sort of issues. If you can figure out a pattern for a static analysis tool and automate a solution, then why not? Then through all of this, when you start building all these little tiny building blocks, for these little small transformations, you can start composing them. So kind of think of them like Lego blocks. So if you've got a recipe that will come in and change a type or change a method signature or something like that, you can plug these together and do larger migrations. So think like JUnit 4 to 5. Like what type of work would be involved to move you to that. Think Java 8 to 11, or more recently, obviously Java 17 just came out. And so I know there's probably folks going, well, I guess we'll be on Java 17 at some point in the next couple of years. We feel like OpenRewrite can get people there quite a bit quicker. And then kind of similar in that vein is also like Jakarta EE. So there's the whole Jakarta EE where it's right, like Jakarta EE8 is using the old JavaX namespace, and Jakarta EE9 will be using the Jakarta namespace. So there's another opportunity that, for automation tools to come along and kind of help with those migrations, get people there quicker. And then finally, you've got like the application frameworks like Micronaut, Quarkx, and Spring, like some of, just to name a few. We actually, what was really exciting is the Micronaut team, when they just released 3.0, and they decided to use OpenRewrite to help migrate their users from 2 to 3 where there were breaking changes. So that was pretty exciting for us, and I think that it's a model we would like to see more of, where these framework owners come along and provide the knowledge of what should be done. And then we use OpenRewrite to actually get that done. So you're going to see that our team has done a pretty good job of like kind of filling out the catalog for these other frameworks. But we would really like to get involvement from some of these other framework maintainers, to come help us build recipes to kind of move users to the newer versions. It benefits them. They don't have to support older versions as long. Your users, there's less friction to moving to new versions. So there's a lot of benefits to it. So call to action for code, maintainability is destiny. It's like you're going to spend 20 or 30% of your time doing this sort of like kind of tedious work. It's I think Jonathan always says it's kind of like doing the dishes. You don't want to do it, you have to do it. And if you're in a Scrum or an Agile environment, trying to get that sort of stuff prioritized and balanced out with all the priorities of your business, a lot of times this stuff can just kind of float to the bottom of the priority list, and it stacks up over time. So this is kind of like that sweet spot. We're trying to like kind of make it easier and less painful to kind of get this stuff into your workflows. And then of course, CD patching, that is a constant, right? Security vulnerabilities come out, you have to address them. If you've got a large organization, it makes sense you'd want to, automate this so you're not spending weeks or days while your systems are vulnerable. So OpenRewrite. I kind of mentioned briefly that it uses abstract syntax trees. So what it's doing is it's taking your source code and converting it into this tree structure. This isn't new. There are a lot of other frameworks that do this sort of thing. Like I know like things like SimGrep do something similar. But this is a little bit different in that these abstract syntax trees have a couple of extra properties to them. The first is there's type information, and that allows us to, like, again, if you look at this diagram, you can see that I know this is a variable, I know this is a while loop, I know this is a conditional, but with the type information, I know the variable is an int, or I know the variable is a string. There's a lot more rich information that kind of comes along with our ASTs. Another property, again, going back to the freedom responsibility, if your source code looks different from project to project, and it certainly does in an open source, if you're going to use this in open source, it could be used anywhere. You really need to preserve the formatting, the original formatting, and you need to do your best that when you make modifications to the AST and you print back out the source code, it needs to be idiomatically consistent with the source code around it. That sounds easy, and it's not. It's actually really, really hard. It's very, very difficult. So the team has spent a lot of effort, getting that aspect correct. So if we do make a change, we do, do no harm. Try to, conform to the styles that are surrounding it. This slide is intentionally kind of vague. You can't really tell what language it is, and there's a reason for that. We're at the Java users group, so we'll be talking primarily about Java. But obviously, with Java projects, you're going to run into XML files. You'll have YAML files, our favorite indent configuration. You'll have property files. So rewrite actually will also parse those into ASTs as well, and it's also format preserving, and that's quite interesting. I mean, it doesn't sound that interesting. Like, sure, you're going to be able to like fix properties and maybe migrate property names and do that sort of stuff, but the interesting aspect of this is that if you have an XML AST, you can then extend that for Maven. So you can build a Maven parser on top of your XML parser. And then your AST is now Maven aware. It's an XML document, but you know that these are the dependencies. This is the plugin management. This is the project name, so that sort of thing. So if you have an AST like that, then now you can start doing smart transformations of like Maven files as well. And then similar, like if you have YAML, you can layer on top of a YAML AST something that knows about Kubernetes constructs. We also have a parser for HashiCorp's HCL language, so you can start thinking like Terraform and that sort of thing. So that's a little bit off topic, and we won't talk about that too much. But just know that there's a lot more, going on behind the scenes. On the immediate horizon, we're actually soon going to be supporting Groovy. And the reason obviously we'd want to do that is we can then layer on top of Groovy, an AST that will allow us to make intelligent changes to Gradle files. So that obviously is very appealing to us. And then finally, also on our to-do list and actively in development is something working with TypeScript. But that's, again, off topic, so I'm not going to go too far into that. So enough words. Let's look at this. This is what kind of got me into OpenRewrite to begin with. I was tasked with migrating an organization to JUnit 5, and I ran into like issues like this. Like, this is the JUnit 4. The expected exception is a rule, and basically you say, I'm going to throw this null pointer exception, and then the framework will catch that and do what it needs to do. In JUnit 5, well, it looks very different. And try to come up with a regular expression that will do this, right? So you can see that the import is now a static import, and it's using this assert throws. You can see that what was in the method body kind of commingled with setting up the expected exception rule is now like inside a Lambda expression. So that's kind of where I want to start our journey with the demo. So I'm going to stop the slides at this point. Should be no more slides except until the end. And hopefully the demo gods are with us. So where I'm at right now is this is a website that's developed by Modern. That's our company. So we work on the open source project. And I want to be clear that all the recipes you're going to see on this SaaS solution today are all in the open source. They will forever be open source. We're never going to get into a situation where some recipes are open source and some are, you have to pay for them. That's never going to happen. So all recipes will be open source. So what we're looking at here is our team has basically gone out and ingested a large number of open source projects. I think we're up to about 60 million lines of code. Jonathan keeps trying to push the envelope and put 20% more in each week. So it's hard for me to tell exactly where we're at, but there's a lot of code in here. So this is a really nice playground to kind of mess around with some of these capabilities of OpenRewrite. So I had just mentioned this problem I had where I need to move from JUnit 4 to JUnit 5, and I have this JUnit expected exception thing. So what I'm going to do now is I'm going to select all the repositories. So I think there's 600 plus. I don't know exact count. And I'm going to run this recipe that was written with OpenRewrite. Okay, and you'll see that there's a lot of projects here. I'm just filtering the results to only those that actually we made changes to. And I'm just going to look for Spring Cloud Config as an example. Okay, so what does this look like? So you can see here, it actually removed, well, let's go up here to the imports. Notice it removed the imports. Notice that it added imports for the new JUnit 5. It got rid of the rule. And it's taken what was the body of this message, and it's removed the pieces that are about the exception. So we don't really care about that. And instead, it just keeps what's in the body and puts it inside this Lambda expression. So you can still see that it's still catching the illegal state exception. You can still see that it's still checking to make sure the message is correct, but it's just doing it now in the JUnit 5. That's automated, and I think you saw, as the results were being collected, it's pretty fast, and it's clear that I was not unique when I wanted to move to JUnit 5. As there's a lot of projects out here that have this same issue. So we have 629 repos in here. So if you're ever wondering about that, that's and we'll talk about this later, because we're gonna provide access to this to folks on the call today and kind of open this up for an open beta. Okay, so I mentioned that it's this is a Java-based talk, but ironically, I'm actually not going to start with what is traditionally Java code, but something that's close. I'm going to go over to GitHub Actions. I don't know how many people are using GitHub Actions on their workflows, for their CI, but something that we weren't aware of that recently we discovered is, the adopt OpenJDK is going to be moving to Eclipse. I don't even know how to pronounce it. So all of a sudden, if you have thousands of repos, you're kind of on the hook to have to go migrate this stuff. So we're like, well, we thought we've got something that knows how to parse YAML. So why don't we write a recipe that will do this? So I'm going to select again all the repositories that we've currently ingested. So again, when I say ingested, what's happened here is we've taken all of the source code from all of these projects and we've ingested them all and created ASTs and stored them, and that's what we're acting on here. So you can see there are a lot of projects that are using GitHub Actions. Let's just try this one. And you can see all it's doing is just changing the distribution. So this is something that, again, is really nice and it seems like obvious. And I think it's a pretty nice win for very little work from us. So that's just an example. I wanted to start with that just because it's kind of cool. So I mentioned that OpenRewrite is both semantic search and transformation. So I'm going to start with a couple of searches. So I'm going to go over to Java, and again, this catalog here, all this metadata is actually generated from the recipes. So the recipes provide metadata for descriptions and names and that sort of thing, tags, and that's how we're generating this. I also wanted to point out that if we go over to the docs page for OpenRewrite, down here in the reference, you go to recipes, you're going to find exactly the same things here. So you'll see the cleanup, format, JHipster. They're all here too. So again, all this stuff is, I just want to be clear that it's available in open source. It's just nice to do it over here because I have a lot of repos to kind of play around with. Okay, so I'm now in Java. I'm going to do a search. And let's search for deprecated APIs. So what I'm going to do here is this is a recipe that will basically go look for, I'm not going to even say what framework I'm looking for deprecated APIs, and I'm going to run it across the entire stack. So basically, this is going to flag every place anybody's using a deprecated anything. So obviously, this is going to be a huge amount of work. But it gives you kind of an idea of how quickly we can kind of operate across all this code, which I think is pretty interesting. While it's working, I'm going to look at Apache Curator as an example. Okay, so what we did here is basically, rewrite. It's good at transforming ASTs. We really realized that searches could just become kind of specialized transformations of ASTs. So what we're doing is we're actually adding a marker into the AST. It's normally not visible if you print out the source code. But when we're doing a search, we have a special printer that when you print the source code back out, it just renders these as comments. And so we're able to use get diffs to kind of find these things. So what's cool about this is you can see that it's flagging that this ensure path is deprecated. So let's go see if that's true. Whew, it is. Okay. So that just gives you an idea of like kind of like the search capabilities, which we think is very compelling. I think this is probably similar to what you would see with something like SimGrep. We don't use a query language. We kind of rely on these kind of pre-built building blocks. But we also have the full power of the Java language or whatever language you're going to end up writing these recipes in at your disposal. So we think it's a pretty compelling story. Okay, so that's finding deprecated APIs. I mentioned already that, again, we can do Java, but you'll notice there's some Maven recipes as well. And if I go over to search, I can do Dependency Insights. So this is kind of an interesting one. What if I wanted to find if there are any places where JUnit is being used in the compile scope? Obviously, you generally wouldn't want that. Let's go find out. So same sort of thing. It's just going to, iterate over all these repositories, and we're going to go see if we can go look at one of these. So, Baba, I think it's in here. We'll wait for it to finish a little bit. I may have picked too many. So the other thing we could do while this is working, let's go back. I'm gonna let that keep going. I'm just gonna scope the search now. There it is. That's the one I was interested in. So I'm gonna say deselect all. I'm now just gonna search this one specific repo because it's the one I wanted to show off. JUnit, compile scope. Let's do it. It may still be busy with my previous query as well. So let's go in here and cancel that one. And then go back. Always going to be hiccups during a demo. So okay, there we go. So let's go look at what this thing actually did. So it's telling us that this dependency here is actually leaking JUnit 4.12 into the compile time class path. So we can look at this a little bit and say, yeah, sure enough, it doesn't have test scope, and it's transitively bringing in the JUnit dependency. So what can we do about that? So let's go back to Maven. Let's go back to core, and we have a recipe to actually go through. And again, what this is doing is it's operating on the Maven variant of AST, which is XML underneath the covers, to basically kind of figure this stuff out. So I'm basically going to tell it, I want you to exclude the JUnit artifact from the compile time scope. What's this going to look like? So now you can see that instead of rendering a comment in here, we're now actually adding the exclusion in the two places where this particular and it's the same artifact is leaking in the dependency. So that's pretty powerful and super easy with again some of the building blocks that we provide. So neat. Let's switch gears now and talk a little bit about security. I'm going to go to Java security, and I kind of mentioned this already, that this is a kind of can be a sweet spot for rewrite. We are just now kind of like we only have 10 recipes to date, but we envision seeing a lot of participation from security organizations to kind of help, basically build out this catalog. So I want to go into core, and you can see we try to give decent descriptions of what these things are doing. So in this case, it's if you use just the Java file create temp, you have an exploitable file permissions. So the recommendation is to use Java inio instead. So I'm going to go ahead and select this recipe, and again, just for the sake of time, I've kind of curated a list of these, so we're not waiting for days on some of these. Not that it's that slow, but I just want to make sure. So I'm going to go with Apache Druid, and we're going to go ahead and run this. By the way, while we're waiting, does anybody have questions so far? Nothing. Okay. People can still hear me, right?
Yes.
Okay, good. All right. We're going to let that go a little bit because it looks like it's going to chew on that a little bit. Oh, there it is. Good. Okay, so let's look at what the change it made. You can see here, it's basically just taking the file create temp direct, creator. Oh man, create temp file, man, a mouthful. And it's just replacing it with the equivalent for the NIO. And you can see here, it's just calling to file. So this thing is basically doing this, it knows that this is indeed, the correct class because of the type information. And then note that, like, so far, all the code you're seeing is formatted correctly. And it sounds like obvious, but it's actually pretty hard to get right. Whether you're using spaces or using tabs, or you've got some strange styles with, like maybe you like wrapping and you want your indentation is different. So there's a lot of work has gone into making sure that when we do make changes, we make them in the right place. The other thing that's probably not obvious here is that import layout, right? So a lot of organizations want their imports to be in a specific order. We're actually trying to detect and maintain order when we're modifying imports as well. So there's an awful lot going on, and it's all automated, which is pretty neat. So as you can see, this is very one specific like building block, if you will. If we were to go back now and look at this, so I picked this one. See this Java security best practices and see how it has a little like 3 boxes instead of the single box. I had mentioned these kind of can be built like Lego bricks, and that's exactly kind of what we've done here. If I want to run this across repositories, and I'm not going to right now, but if I wanted to, then I could, basically check to make sure if I have any XXE vulnerabilities. This is where, like, if you're downloading DTDs, you get some denial of service attacks, that sort of thing. So there are lots of things we can automate with security. So that's, I think, another kind of sweet spot for rewrite, and I think that we're going to see a lot of growth in this area around this. And as you can see here, I picked one repository, but you can imagine if you had a security vulnerability and you wanted to do it across your entire org, you could use a tool like this to do it quickly. And you're not going to be bothering your developers. And you're benefiting from the fact that the community has already written a building block to take care of this. So I think that in the future, you will see security organizations with tools like this be able to provide not only, hey, this is a vulnerability, but hey, here is a recipe to fix it as well. And then it's just a matter of just doing the work. So pretty compelling. Let's go back to Java. I'm going to try to do this quickly, or somewhat quickly, because I want to leave a time for some coding exercises. I'm actually going to do some common static analysis issues. So these are things like SonarQube might report. And I'm going to do this on on the OpenRewrite ones. Why not? So I'm going to pick OpenRewrite's repositories. I'm going to select those. Got 20 of them, and I will just run this whole mess of issues. So cool. So let's see here. Let's go look at OpenRewrite Spring and see what it did in here. So again, you can always tell what recipe made the change, but we'll always report it here. So you can see that in this case, it's basically just flip-flopping, the string so it's first, so we don't get a null pointer exception. That's pretty much it. Don't think I see any. Oh, removing unnecessary parentheses. So this is here, like, why have you added parentheses around this typecast? You don't need them. So it's just doing small cleanup tasks like this. So one thing that you can do in this, and I encourage once we have access to folks, is don't be afraid to hit, let's go ahead and create a pull request. So if you don't have access to the repo, like again, these are all open source. The default behavior is going to be, hey, I'm going to fork this on my own, under my own GitHub account. Let's go ahead and try it. Even though I'm a committer on this, and I could, if I wanted to, just go out and do this directly. And what's neat about this is now you're dropped into your normal workflow, right? This is just another pull request, just like everything else. Nobody knows that something automated this, so you can basically look like a hero if you come in here and you do like you have a pull request that fixes like 10,000 of these things. So we definitely hope people kind of like exercise this a little bit and just to get a feel for this. So if I want to, I can create a pull request, and again, now we're in GitHub and everything works. So neat. Okay, I'm going to move ahead a little bit now. I was going to try to do a couple more, but I don't want to. I think that these kind of get obvious after a while. I want to move over to Micronaut. So I mentioned Micronaut was kind of the first framework owner that kind of embraced this this approach and said, hey, let's go ahead and build some recipes together. And I also wanted to kind of like show what the experience is like when you're not using this fancy UI that we're looking at here. So I actually have basically cloned a repo that happens to be in the SaaS. I'm not sure what this looks like in the SaaS as well. You see if I do a diff here, all I've done is I've added the rewrite plugin. I'm activating the Micronaut 2 to 3 recipe, and I'm just adding the basically the dependencies that have the rest of the contents. So that's it. Pretty straightforward. Rewrite, run. Okay, so this is going to do exactly what you're seeing on the SaaS, but now it's doing it locally. It's not, obviously it's not as efficient. You're going to be doing this one project at a time, but it gives you a chance to kind of like, what this will do is it will make changes to the source files on disk. You can create a pull request there. I'm actually going to step away because it's actually just front end building, and we'd be sitting here watching it do front end. So what I'm going to do also at the same time is actually run the same transformation on the SaaS. Let's see. Let's deselect all. All right, so I'm going to run the same recipe, and I am going to pick the one I just was playing with, which was the JHipster sample Micronaut app. I'm pretty sure that's it. Yeah, that one. Okay, and I'm going to do a run on this. So the difference here, of course, is that the AST has already been ingested by this by the SaaS. So if I come in here and I look at this, some kind of interesting things you'll see is because we have some semantic awareness of what's going on with the Maven file, we're actually making sure when we update the dependency, we're actually updating the property file. We're not actually updating the dependency version itself, right? The version using the property. We will follow the properties until we find where we need to make that change. So that's it's kind of interesting. We're doing other things like they added the requirement of having this introspected annotation being added to classes. this kind of follows on. There are a couple other things like, don't use this once per request HTTP filter. Instead, use this. So we got a lot of help from them with respect to what changes should be made. So we're very comfortable if these are the correct changes. So it's part of the reason I want to show it off. In the meantime, this should be done. You can see that that rewrite basically did the same thing that the SAS was doing. So if I do get diff here, you're going to find the same thing. Maybe. Here we go. So you can see it's changing the properties. It's there's a recipe I added, and you're going to find that it's adding the singleton introspected. Thing changes, just kind of a different medium for doing that. So I just wanted to touch base and kind of like show you what that looks like. Okay. So if I'm going to do Micronaut, then I probably should not play favorites here. We're going to go look at Quarkx. So go over to Java. Quarkx. We have the same sort of thing. So we have a migration to take you from Quarkx 1 to Quarkx 2. So again, this is a composite recipe. So I just want to kind of like just point this out again. We're actually doing, all we're doing is we're taking a bunch of these smaller building blocks we already have, and we're composing them to build the full migration. So I'm going to deselect all the repos, and this time I'm going to use this Quarkx demo as an example, again, just for the sake of time here. Okay, that was fast, better. And you can see it's doing the same sort of thing. It's modifying the Maven build file. It's fixing the correct versions. This thing is doing a few more sophisticated transformations. You'll see here that it's taking this apply transform, and it's now basically making it transform and calling it select. So it's, that's an example of, try to automate this with regular expression. You just would never be able to do this sort of thing. This is the type of capabilities you have when you have an AST that is both type attributed and also format preserving. That's those two attributes I can't stress enough really make this possible. Okay. One last one, and then I'm done, I think, with all these demos, so I don't lose too many more people. And I'm just going to do the spring, like a spring migration. So we'll do spring framework, and we'll do 5.3, and we'll clear. And this time we'll do the Spring Cloud projects. And select those and give it a run. See what happens. Git run, right? Oh, there it is. Oh, I was too impatient. Okay, let's go here. So you can see here, it's basically made a bunch of changes. Let's go look at Spring Cloud config again. Why not? And you can see that one of the primary changes here is it's changing string utils to object utils. So they clearly in 5.3 they moved all the stuff from object utils to string, or from string utils to object utils. Give you an idea. Like I think of if there's anything more interesting in here. That looks to be about it for this one, but I just want to point out these are the type of things that you can do with this framework. Okay, so you can kind of go back to the catalog a little bit, and you can see where this is going. We have, like I mentioned already, we have a parser for HCL. So because we have HCL, then we can do these Terraform recipes. This is kind of off base. I'm not going to get into these, but best practices for AWS, best practice for GCP, for Azure. This thing will basically rip across all of your repos and make these changes in an automated way. So it definitely feels like there will be a lot of time savings when people start using this. Okay. At that point, I'm done with the demos, just to kind of show the capabilities of what you can do with these building block recipes. Before I get into a quick coding exercise, are there any questions? Okay, well then I will keep moving. All right, so something that's on our catalog, go figure, is a recipe that will add a serialized version UID to a field or to a class that implements serializable. It's a relatively straightforward thing. I'm sure we've seen our IDE kind of make this recommendation. You have a serializable class. It says, hey man, you should probably put the serialized version UID on there. So what I'm going to do now is I've dropped into just a little sample project. I've already got the development environment set up, and I'm extending a recipe. I kind of mentioned already that recipe is kind of like all those things you were seeing on the SaaS, all those things you see on the docs. They're all recipes. The recipe always has metadata. So like the display name's the only thing that's required. So I'm just going to say here real quick, add serial version UID to a serial when it's missing. Okay. So again, all this metadata is going to get rendered in both docs and through the SaaS. Okay. Other thing that's kind of interesting to point out is, if a lot of these tools use Markdown, so you can do things like that if you want to get creative. Okay. So the next thing I'm going to do is I'm going to create a visitor, and I'm not going to you're not going to watch me type all this stuff out because that would be boring, and we're running out of time. So I'm just going to paste it in. Jonathan does this live. I'm just not as fast as he is. So I'm going to do a little cheating here. Okay. So what is going on here? Do I have a statement? What happened here? Weird. Okay. Okay. So I mentioned already, the recipe. Think of that as like the wrapper with all the metadata and any configuration options. You can see if you wanted to get more creative here, like right now, I'm going to default the serialized UID to 1, but you could see this being configurable, right? Like, hey, I want you to make this some random long, or I want you to make it 1. That's something you could expand on and make this into a recipe that then people could include in their composites and configure this to do certain things. So the framework operates over the AST using a visitor pattern. So basically, if you were to look in here at, if I were to go override methods, you'll see that there is a visit method for pretty much anything you could think of in the Java language. So what this is doing is it's going to visit all these various elements. The most common ones that we typically write recipes against are visit class declaration, visit method declaration, visit method invocation, like when you make a call to a method. So just know that we are a very friendly bunch, and we're on Slack. There's lots of documentation on how to make this work. It can be a little overwhelming when you first get in here, but when you see how little code is required to do this sort of work, it's, I think, well worth the investment of kind of figuring out kind of how this stuff works. So what I'm doing here is I'm basically saying, okay, cool, I'm going to visit the class declaration, and I'm going to check to see if this AST element, so this class declaration, you can see it, I'm basically grabbing its type. So again, if it's type attributed, I'm going to be able to determine whether or not this thing actually implements serializable. So this is going to include looking at the interfaces that this thing implements. It's going to look at the superclass. It's going to look at the superclasses interfaces, and so on and so forth. So because we have this information, we can do some really intelligent things. You wouldn't necessarily be able to tell some of the classes are serializable because it might be an interface that's implemented three layers up the parent. So that's what's really interesting about the type attribution. And all this is doing is just going through the statements in the class declaration, going, are you a variable declaration? And if you are you serialized version UID? And if you are, then cool, I know you're there. I'm going to go ahead and just return. I'm not going to modify this AST. However, if I drop through this and I go through all the statements and I do not find it, and I am actually implementing serializable, then I want to add it. So what I'm doing here is I could do this by hand. Like I could try to create the AST model by hand. It's complicated. Like it's stuff that you don't necessarily want to do by hand. That's what this template is doing. What it allows you to do is it allows you to take snippets of Java code like you would write in a Java file, and we'll convert that into an AST structure. That's our AST structure, and then insert it into the correct spot into this existing AST based on where you tell it. That's what these coordinates are doing. And furthermore, what it will do is after it inserts it, it will then format the area around it to make sure that it is idiomatically consistent with the formatting around it. So that's really it. That's all the code I had to write in order to basically add this to a serializable class. I've created a couple of tests already. This is using a test harness that we've created. This actually is written in Kotlin. And we primarily use Kotlin because we wanted to use the multi-line strings. We know that obviously Java 15 added multi-line strings. We will be likely moving to that soon. And so all I've done here is I basically am creating. I'm basically saying I want to exercise the test I just wrote, and I'm providing it a parser, and you can see the parser doesn't need anything special in terms of class path. I'm just using normal Java classes here. And then all I'm going to do here is I'm just going to assert that given this source code, it's not going to change anything because this thing doesn't implement serializable. And then this one here, you can see it implements serializable. Then what we're basically saying is that if this is the original source code, we expect it to look like this when it's transformed, where it adds the serialized UID. And then finally, if it's already present, there's no need to add it again. So that's just asserting that we aren't making a mistake there. So I'm just going to run these really quick to give you a real quick idea of what this looks like. And then I'm going to break it too. I don't use foo, I use Fred. So if you're ever wondering why the heck I'm using Fred instead of foo, I don't know, I'm trying to be different. So you can see all three tests pass. So is this really actually working? Let's find out. Let's, I don't know, add an extra blank line here and run again. Good. So we can see here that indeed it did detect that. So I can't stress it enough. Format preserving is really a thing. It seems obvious when you look at it as a human. Well, of course it should be like this, but it's not as obvious to the compiler and not as obvious to our framework. So we do an awful lot of work in there to make that work. The last thing I want to touch on, and then I'll open it for questions. I'm almost done. Is I want to go back to my recipe, and I kind of mentioned this template and this, with template and coordinates and whatnot. What if you wanted better examples of how to use this template? So it occurred to Jonathan about a week and a half ago that, hey, wouldn't it be cool if you could actually operate on a search from your IDE? So he went out and built a plugin. So if you go out and look at the in the marketplace, there's a Modern plugin now, and what this is going to do is launch a browser and issue the search of all places where it's using that template. So what's cool about this is you get a better idea of how we're using the template. You can see here at, oh, cool, we actually can allow parameter substitutions. You can actually see here, that how it's using coordinates, how it's passing things, and that sort of thing. So like if you're really interested in this stuff, you can also go to the class and figure out what's going on. So this is like the new, I could see this becoming the new Stack Overflow, in that we've got like 65 million lines of open source code there. If he uses an example where he wasn't sure how to remove quotes around the keys on JSON, ended up going to Stack Overflow and found a solution that had been deprecated, able to use this type of search to kind of find the solution quicker. So with that, I think that's about all I have to talk about. I just wanted to bring up my slide deck one more. I have one more slide. Thanks for coming. We do need your help. Please just star our repo. It helps us. I know it sounds silly, but it helps elevate our presence out there. We ask that if you've got ideas there are so many recipes. Like right now, our team is going through kind of a backlog of SonarQube issues and looking for targets that make sense to move into this framework. But we know there are others. We know there are other frameworks too, like like Drop Wizard or that sort of thing. So please come in and issue or ask us questions. Follow Modern Inc. That's our company. So again, the team that works on the open source side of the project is all working at Modern, but we've got contributors already. And then finally, as I mentioned, if we're hoping that if you really are interested about this stuff, you can go to appmodern.io and play around with that very UI that I was showing and demoing all these different projects with. It's still an open beta. We just opened it up recently. So, please bear with us. There's a lot of construction going on with the platform. And we are always looking for feedback on, hey, this isn't working. You would be surprised at how sensitive we are when we see an extra space before a brace when it shouldn't be there. We're like, those type of things make us mad. We want to fix them. And not mad at the person reporting them, but mad that we didn't catch it. So please, come join us. We actually have a Slack channel also. You can get to that via our GitHub page. I think it's also available on our docs page. And I think with that, that is all I have.